Before light writes its name across the cosmos, geometry whispers, "Come closer. Look past the blinding glare of a billion suns, past the clouds of incandescent gas. There is an order here, a design. The spiral is not an accident." Now, let's dive in. Imagine we're crossing the void at light speed. The starfield warps, the colors shift, and the galaxy ahead resolves from a celestial portrait into a living, breathing environment. Stars whip by in a torrent of light. The arms curl around us like a cosmic hurricane, a vortex of stars and dust spanning 100,000 light years. It's beautiful, chaotic, and overwhelmingly vast. So what is the secret geometry holding this magnificent structure together? What unseen blueprint dictates this perfect swirling form? Here's the wild reveal. Spiral galaxies aren't random, chaotic swirls of matter. They are breathtakingly organized. Their arms almost perfectly trace a super clean mathematical pattern called a logarithmic spiral. It's also known as the spira mirabilis, the marvelous spiral. What makes it so marvelous? It has a unique property. As you move out from the center, the curve expands, but its shape remains unchanged. The spiral always maintains the exact same angle relative to its origin, like a perfect, self-similar pattern scaled up over and over into infinity. Zoom in or zoom out, the fundamental geometry of the curve looks exactly the same. It's a principle called equiangularity. That's why these galaxies feel so balanced, so inevitable. Their structure is born from a fundamental mathematical truth. But wait, there's a paradox. The galaxy rotates. Stars closer to the center orbit faster than stars farther out. So why don't the arms wind themselves up into a tight, smeared-out blur and vanish completely? This is called the winding problem. The solution is mind-bending. The arms aren't made of the exact same stars forever. The stars are just passing through. They're more like cosmic traffic jams, a pattern of higher density moving through the disk. Stars and gas, in their orbits, flow into a slow-moving gravitational ripple, a density wave. As they enter this wave, they slow down and bunch together. This wave is what compresses the interstellar gas, triggering gravitational collapse and sparking furious bursts of new star formation. Then, as they pass through the crest of the wave, those newborn stars accelerate again and drift onward, leaving the arm behind. The wave itself, the pattern, is what persists, maintaining the galaxy's spiral shape, just like a stadium crowd doing the wave. The people move up and down, but the wave travels around the stadium. The stars are the people. The spiral arm is the wave. Now, let's talk about the pitch angle, that constant angle of the logarithmic spiral. It defines the tightness of the winding. Some galaxies have very tight corkscrew arms with a small pitch angle. Others are laid back and open, with a large pitch angle. This isn't just an aesthetic difference. That angle quietly whispers the galaxy's most profound secrets. It's a direct clue to the dynamics happening at its core. For instance, fast rotating disks and, fascinatingly, more massive central supermassive black holes both tend to wind the arms tighter, creating a smaller pitch angle. The black hole's immense gravity tugs on the inner disk, influencing the entire structure. This relationship is so reliable that astronomers can literally measure that pitch angle from a simple photograph and use it to estimate the mass of a black hole millions of light years away. It's geometry as a cosmic telescope. Now, if you've spent any time on the internet, you've probably heard people shout golden ratio at every spiral they see. The golden spiral is a specific type of logarithmic spiral with a pitch angle of about 17 degrees. It's a cool idea, a beautiful link between math and nature, but reality is a little spicier. While some galaxies come close, most spiral galaxies do not match the golden spiral. Their pitch angles vary widely, typically from 10 to 40 degrees. The universe isn't married to one special number. It uses a whole menu of angles. The final shape depends on a complex interplay of the galaxy's total mass, its rotation speed, and the distribution of its invisible components. And that brings us to the biggest ghost in the machine: dark matter. Think about it this way: if you spin a pizza dough too fast, the toppings fly off. Gravity works the same way. Based on all the stars and gas we can see, galaxies are spinning dangerously fast. So fast, they should have flown apart billions of years ago. The solution? A vast, invisible halo of dark matter, providing the extra gravitational glue needed to hold everything together. This halo shapes the galaxy's rotation curve and is crucial for locking in that stable, long-lasting spiral structure. The beautiful geometry you see? It's the visible matter tracing a gravitational field you can't. The spiral arms are painting the shape of the unseen. Let's go deeper into the arms themselves. They aren't just pretty, they are the galaxy's engines of creation. Those crisp, bright arms are cosmic star factories. The leading edge of the density wave is a shock front, piling up gas and dust. This is where the magic happens. Massive, blue, intensely hot, but very short-lived stars ignite along the crests of the wave. They burn through their fuel in just a few million years, a cosmic eye blink. They live and die before they have a chance to drift far from their birthplace. They then fade, leaving the longer-lived, older, redder stars to continue their journey through the disk. That's why the arms pop with such brilliant blue-white light. They are constantly being refreshed with new bright stars, making them the most luminous features of the galaxy. And if you think a galaxy is a flat, two-dimensional plate, surprise, the reality is far more dynamic. The disk flares, getting thicker at its edges. It warps, bent out of shape by gravitational tugs, and it even ripples, with waves of stars moving up and down through the plane. Galactic mergers, the formation of central bars, and even gentle tidal nudges from neighboring galaxies can twist and sculpt the spiral, creating spectacular rings, or perfectly formed grand design swirls, or sometimes just messy, patchy, flocculent patterns, like foam on a cosmic latte. Here's a final mind-bender for you. Take the pure math of a logarithmic spiral, give it a specific rotation speed, a realistic mass distribution including dark matter, and add just a sprinkle of chaos for local star formation. And you can run a simulation that evolves into a galaxy that looks eerily, breathtakingly real. The underlying code of the cosmos is simpler than you think. The same fundamental equations sketch the arms of hurricanes, the chambers of a seashell, even the arrangement of a sunflower's seeds. It is spiral logic, echoed across every conceivable scale. So what is the ultimate secret of the spiral galaxy? It's not magic. It's the elegant dance of angular momentum and gravity, tuned by the invisible hand of dark matter and sculpted by persistent, star-forming waves, all stamped with the timeless form of a logarithmic spiral that stays true to itself, no matter how far you zoom in or out. So next time you see a photograph of a spiral galaxy, don't just see a pretty picture. Look for the pitch angle. See the traffic jam. Picture the invisible halo. That curve is a signature, an autograph written by the fundamental forces that shape our entire universe. And if this journey just upgraded how you see the night sky, you know what to do. Let's keep zooming.